Good morning, geometers. I hope that you're doing well. I'm glad it's Friday. How about you? Okay, so here's the thing I wanted to tell you before we even get going on the lesson is that we are finishing up our chapter today, chapter 11, and we're preparing for a quiz next week. Quiz is your keyword number 1, by the way. So we're planning for a quiz next week. That quiz will be on Thursday. Okay, so today we're going to do the lesson, and you're going to have a work day on Monday that is going to be working on assignment 63. So the only thing that you have to do today is to turn in your assignment 62 that you did yesterday and watch this video. So there's that. Make sure you're writing down your keywords, like the first one that is quiz, because your quiz is scheduled for next Thursday. You have a work day Monday. Tuesday will be a quiz review. Wednesday is our last no work day, because we are heading towards the end of the year very rapidly and we need to finish some things up. All right, so that's enough of a good introduction. We're going to talk about circles and proportions today. So when you have circles and you have lines that go through them or around them, or different types of interactions, like these are chords. We had some properties about the angles that the chords make before. However, now we need to look at the properties that the pieces of segments make. Okay, so what happens is when you have these two lines that intersect inside the circle, if you multiply this one times this one, that equals the product of this one times this one. Okay, so we're not using the word proportional here. Okay, it's the products. Okay, the products are equal. Okay, so we're going to take a look at, first of all, we're going to just take a look at why that works. So a little mini proof here. So I'm just going to draw in a couple of extra lines. Okay, we're going to put in some labels, A, B, C, D, E. We draw in this line. We still have our original, and we're trying to show why W times X equals Y times Z. So the first thing that we can consider is that we have vertical angles here. Okay, so since vertical angles are congruent, we can say that those two angles are equal to each other. Okay, so here's another one. This one and this one, okay, they are congruent angles because of what we know about intercepted arcs. Angle E intercepts arc BD, and so does angle A. We don't have to know how many degrees it is, but we know that they're equal because they intercept the same arc. So now, since we know that we have two angles that are congruent, that automatically tells us that the triangles ABC and DEC, okay, so ABC, and it should say in a different order. Let me fix that. Okay, I'll fixed so that our corresponding parts line up. So we want to make sure that you're doing that and we're careful. So triangle ABC is similar to triangle EDC. And how did I figure out that there was a mistake? Well, A is the one that's similar to E, so they have to match up. So that's a good example of how you can go back and make sure that you haven't missed as far as getting your corresponding parts, which are important in similar triangles, because that's going to help us to show that proportionally Y goes with X, because Y is BC and X is DC, like W goes with Z. Once again, these are our corresponding parts. And this is what we know about similar triangles. So when you cross multiply and use the cross product property, we get the wx equals yz. Now you are not going to have to show the proof, but it's good for you to have that in the back of your mind so that you know that these don't come from nowhere. So let's apply it. This problem is something that you are going to need to be able to do. So you have these values here, and we're going to use this theorem, so make sure that you write this part down. If you didn't write the proof down, that's okay, but make sure you write this part down. All right, so we have our two chords, and we'll need to take products. Product is your keyword number 2. The product of 6 and 3.5 equals the product of 2 and x. Okay, so this is some of the simplest calculations that you will have done all year. It's hopefully not going to be too difficult for you guys. So 6 times 3.5 equals 2 times x using products. 6 times 3.5 gives you 21. And then divide by 2 and you get 10.5. And that's just finished and done. So once again, second keyword is product. This one again, products for this, because you've got your chords. So 10 times a plus 2 equals a times 15. There you go. 15 times a equals 10 times a plus 2. Be careful on this one though. Watch out for your parentheses. Okay, so here we've got parentheses. Distribute. Then you need to get the a only on one side, so we'll subtract 10a from both sides. That gives you 5a. Divide by 5. You get a equals 4, and that's all you were asked to find in this question. If you were asked for the length of this segment, you would say it's 4. The length of this segment is 6, just in case you wanted to know. So chords have a nice simple equation for that. Okay, so we then also have to look at secant lines. Please write down secants. That's your keyword number 3. So keyword 3 is secants. And it also has to do with products, which is really cool because we don't have to be wondering if it's products or not, but we do need to know what it's a product of. So it's a product of y and x plus y. Okay, and I'm going to show you a little mini proof as far as why this works in a minute. But you take the product of y and x plus y, and that equals the product of z and w plus z. This is your important part. Make sure you write down this drawing and this formula and this theorem about secants. Okay. Once again, your third keyword. All right, so here's our little mini proof. I'm going to draw in some extra things here. We draw in this, draw in this. If you don't write this down, it's okay, but please pay attention to the whole thing. Okay, so we have these drawn in. Once again, we want to think about the idea that these two, DAE and DCE, both intersect the same arc, so that makes them congruent to each other. All right, so we could mark in some congruence here. Oops, it's not going to let me mark into some congruence, but we know that it's congruent. Maybe it'll let me mark it with this one. Nope, not going to let me mark there. That's okay. So congruent, congruent. Angle B is congruent to angle B. That's reflexive. So we've got an angle, angle. We have the two triangles are congruent. Triangle BAE and triangle BCD are similar. So since we know that they are similar, what that tells us is that BE goes with BD, like AB goes with CB, because they're similar, and then you can cross product them. Okay, and when we do the cross products, we find out that they're equal, so that's important. Okay, so our cross products being equal. Okay, so with our cross products, we can solve. In this, we're going to use our products because we have here our two secants. And important that you put the numbers in, 8 and 16. And x is what we're trying to solve for. We're trying to find dE, so we're putting in a variable. And we put in our 14. Now we do have to keep in mind you're going to have to do a little bit of adding here in order to solve it, but we need to take 16 times 8 equals 14 times that thing, and we have to think about what that thing is. Oops. 16 times 8 plus 16, I misspoke a second ago. 16 times 8 plus 16, the whole thing, equals 14 times x plus 14. Once again, you've got to multiply this one times the whole thing. 16 times 8 plus 16 equals 14 times x plus 14. Then you simplify it, you distribute, then you subtract 196 from both sides, then you divide both sides by 14, and you need to divide that out. You can use the calculator, 188 divided by 14. This is the type of thing, here's your approximate answer. Or if you want to, you can make it into a reduced fraction and then a mixed number as well. Remember, when you make a mixed number, you have to take the numerator divided by the denominator and the remainder over the divisor for that. Okay. Now, moving right along. Here we have a secant and a tangent. Secant and tangent has this relationship, and I'm not going to do a proof of that one for you, so we're just going to jump right into an example. Secant and tangent. The secant part looks the same as it did before, y times x plus y. But the z squared is a little bit different, so we'll take a look at that one. And when you do this, this is the part that's squared, and this times this. Okay? The tangent, there's not two pieces to it, so we've got the tangent times itself, and 8 times x plus 8. So we have 100 and 8x plus 64. We solve this, and we end up with 9 halves, which is 4 1/2, which is 4.5. Now, some of you hopefully didn't just write down this last fourth keyword and turn it off because you need to hear what I have to say about June. Okay, the reason that I'm saying June, I told you a minute ago at the beginning of the lesson that we have your quiz on the sections 4, 5, and 6. Not 3, 4, 5, and 6. 4, 5, and 6. Chapter 11 is on Thursday. We are then going to do the beginning of chapter 12. Okay? And then we'll have a quiz on the beginning of chapter 12. And what we'll do then is review chapter 11 and chapter 12 so that your last test will not be a final exam, but your last test that will be on final exam day, which is June 9th, because you're an even period class. June 9th will be your last test day. Now, put that into your mind because that's the same for all of the even period classes. Will have your final exam, or in this case for geometry, your last test on June 9th, which is Tuesday. So on June 9th, you will have a test that covers chapter 11 and the part chapter 12 that we will cover. So it will count as a test and a half because it's covering a chapter and a half. So that's how that goes. So make sure that you're understanding that we are having a quiz on the last part of Chapter 11 on Thursday, but we will not have the test that covers that until June 9th. Okay? That's it. And I hope you have a happy Friday and a good weekend, and come back on Monday ready to spend your time doing that assignment that goes with this lesson. God bless you.